Welcome to another live interview from Strange Loop 2022. Today we have with us Felix, who is a principal engineer at LinkedIn. How are you today, Felix?
Pretty good.
Yeah.
You?
Yeah, I'm doing great. Thanks. It's a good conference. How was your conference experience so far?
Well, I gotta say I was feeling a bit anxious about the talk I had to give, so I'm feeling much more relaxed now that it's over.
That's great to hear. It's a very common sentiment.
Yeah.
So do you want to tell us a little bit about your background, sort of how you ended up at Strange Loop this year?
Yeah, we were shooting to open source Venice towards the fall. So at some point, I started looking for what conferences had a call for presenters opened around that time frame. And Strange Loop looked like the best conference by far of all the ones I looked at. So I took a shot, submitted here, and I'm happy they took it.
Awesome. So, well, I was in the audience for it. So the talk is about open sourcing Venice. Do you want to just give us an overview of what you talked about?
Yeah. So we talked about essentially a lot of the user-facing aspects of Venice, which is a derived data store for ingesting data from Hadoop and stream processing jobs, and then how to get data out of Venice, which is mostly used by like machine learning applications, but other ones as well. And we talked a little bit about also what it's like to operate Venice at our scale. So hopefully that was interesting. I don't know.
Yeah, I found it fascinating. It's not often we get to peek inside these huge petabyte scale systems. LinkedIn's obviously got a tremendous legacy in history, releasing Kafka and Samza. Do you feel this is one of those pivotal moments of open sourcing internal infrastructure?
Yeah, I certainly hope that it becomes useful to the industry. Open sourcing is sometimes hit or miss. You have something that's useful internally and you don't know if it will be useful externally. But I certainly hope Venice is one of those that will be useful. And we're looking forward to engaging with the community to try to make that happen.
Yeah, there's lots of interesting use cases. I really like the way you presented. Here's from an end user LinkedIn perspective, these are the features. This is like people you may know, or the ads team, like using it for the A/B testing. But before you went on this journey of building Venice, were there other technologies you evaluated? Did you want to share about the background as what was the real motivation behind Venice?
Yes, certainly. So when I joined LinkedIn, originally I was in the Voldemort team. Voldemort at some point was running basically every scalable data problem at LinkedIn was on Voldemort. And then eventually we started chipping away at it with more specialized solutions, right? Search moved to another system, graph moved to another system, etc. And the last sort of big chunk of use cases that remained in Voldemort at the time I was there was what we call the read-only use cases, which are ones that do a batch replacement of the data coming from Hadoop. And that was a pretty successful offering. Like it gave great productivity to the AI engineers and other data producers. But stream processing was like coming up in these days and was the early days of Samza and the other stream processors. And we wanted to have a data store that would be capable of doing for stream processing what Voldemort read-only had done for batch processing. Essentially, unleash the data so that it becomes queryable by online applications, right? Not just stay stuck in the grid it was processed in. So that was a vision, and it was essentially you could say a lateral translation of the scope of Voldemort. We would cut out certain things out of the Voldemort scope, but add also other parts. So essentially readjusting the scope of Voldemort. And we evaluated whether to just keep building on top of Voldemort also. But there were many details we didn't like. We wanted to modernize it. So in the end, the decision was to build Venice.
That's great. And you used like various other components to assemble Venice. You mentioned Apache Helix. Do you want to say a few words about like the decisions you made there?
Yeah, definitely. So although we're building Venice as a new system, we're not building everything from scratch, right? We are actually, I would say, standing on the shoulders of giants. Like we heavily leverage Apache Kafka, Apache Hadoop, Felix, Samza. We are also pretty big users of JUXT, which works great for us, and a few other technologies, Netty, etc. So we definitely leverage a lot of open source, and Venice is the orchestration, partitioning, replication layer that ties all these pieces together. And after having leveraged all these open source things, we wanted to give back and let Venice itself be open source as well.
Yeah, I really like the way you described how this layer on top of Venice, which makes it into more of a building block for other people to build their own distributed system designs, right?
Yeah, the part we call Da Vinci.
Da Vinci, yeah.
Yeah, that's an alternative client library where people can essentially take the Venice server and embed it in their application. So they get all of the storage and ingestion part of Venice, but then they can query the state inside Venice directly from local state embedded in their application, which gives them blazing fast performance, right? It's essentially microsecond latency, depending how you configure it, of course. Whereas, doing a query to their remote Venice backend, which we call classical Venice, that is going to be more like a millisecond class latency, so several orders of magnitude higher. So depending on the use case, we've got these like various levels of integration for like kind of the layman and the power users. Yeah.
And I used some terminology around caching, and I like this embedded. Da Vinci was sort of a cache. Yeah. And in my mind, I'm thinking, this sounds like incremental view maintenance or like a materialized view or something like an index.
Yeah.
Is that kind of how you also think about it? Or was the choice of terminology around caches like really specific?
Yeah. So certainly we have materialized views kinds of use cases in Venice. So for example, people maybe want to denormalize something that is more specific to the use case they need. Maybe they'll do some projection of some upstream data set or join a few data sets together, massage it in other ways. And then the output of those transformations goes into Venice so that when they query it, it's all pre-packaged the way they want it with none of the stuff they don't want. And so when you have this materialized view, it's pretty flexible at that point, whether you want to query it remotely, which is what we call the classical Venice APIs, or embed it directly inside your application, where you can get like memory class latency or SSD class latency because the data is right there, like local to your process.
And without going too much into detail on how LinkedIn managed the infrastructure, but did that mean that sort of the cost of running those machines is on the other teams? So it's not sort of part of your service. It's like they have to find their own machines to provision, or is that sort of, you have to help them with that as well?
Yeah, that's right. The idea essentially is out of these two offerings I keep talking about, classical Venice and Da Vinci, classical Venice is the service version of Venice. So it's extremely easy for users to leverage. They can just query it. They have very little operational overhead there. The Da Vinci part is more for power users because now their system carries state. So it is a bit more operationally intensive potentially for them. And there's different levels of depth that they can go to depending like what functionalities they use. So for example, I had mentioned in the talk, the ads use case is ingesting all the data. It doesn't do partitioning. So that's pretty easy still, assuming the data set is small. Whereas the other use cases I presented, like the search infrastructure, is leveraging Da Vinci in a partitioned way. So then we are relying we are letting them essentially own their own partitioning logic. So it's a much more sophisticated system that they're willing to own and maintain and operate. And then, everybody has RAM, of course. That's easy to get as long as you don't need too much of it. But if you need something more fancy like an SSD, then it's the responsibility of the teams that want to have that to procure that if they're using the Da Vinci offering, which is just a library.
Yeah, it's really nice. You have a sort of spectrum, but like a consistent API across that spectrum.
Yeah.
So one of the things you hinted at in the description to your talk, and was CRDTs. I can't remember if I heard mention of it on in the talk itself, but I gather that's in relation to the active replication, which is worth asking about as well. But I wanted to know if that was part of the partial update stories. So you described how sometimes you want to update like certain columns, but not others, and you want to avoid doing read then writes. Yeah. So you have this ability to do this. Does that use CRDTs as well?
Yeah, that's right. So unfortunately, I ended up with a little bit too much content. So I didn't go in as much detail as I would have wanted to on the CRDT part. But essentially, we leverage that for when we have concurrent writers that are affecting the same row of the table or same record, you can think. Either within the same data center or maybe in different data centers, they're concurrently writing to that record. we want Venice to be capable of having a deterministic way of resolving the conflict, right? And we support various types of operations, like let's say updating a full row of the table. If two people do that at the same time, then it's just whoever did it with the highest timestamp wins. So kind of a typical conflict resolution strategy. But where the CRDTs come in is like you hinted at, like when we do partial updates, then at that point, we actually perform the conflict resolution at a per column level. So that means if there are partial updates getting used in that data set, when a write comes in, the write could either be fully applied or fully dropped, or it could even be partially applied if it turns out that only some of the columns affected by the write are more recent in the incoming operation than what's already there. So yeah, that's I think a pretty cool part of the system that I didn't have time to go in more depth. So I'm glad you asked.
Yeah, well, I'm sure there'll be lots more talks and content coming out about all this. Was there something novel in particular, like you drew inspiration from like academia, or is this do you think this is a sort of fairly like a novel take on how to do CRDTs in this sorts of systems?
Yeah, so it's funny the way it happened. At the time that we were starting to build these things, like I had this kind of intuition that there's got to be a way to make concurrent partial updates that arrive out of order converge to a deterministic outcome, right? And so I came up with a rough algorithm that seemed to work, but I had no proof that it worked. And then not that long after that, I went to a meetup that was similar to Papers We Love, a similar idea. And that's where I heard of CRDTs. And then I started binge reading that, and I realized, oh, there's some people that already thought of that and went much deeper than I did, even with other types of data structures that I hadn't thought of. And they even wrote like mathematical proofs that it will for sure converge if you implement it correctly, of course. So that was reassuring that it wasn't just a napkin draft. There's some people that thought much more deeply about it than I did. So yeah, in the end, we ended up making sure basically that we were leveraging those concepts, not deviating away from that. Where I think, so that stuff, I would say we don't deserve credit for having done something novel. Like in the end, academia had already figured it out 10 years ago. But there is something in that space which is interesting, which is not mentioned in the talk, but that we hope to open source as another extension, essentially, which is internally we have a system that audits Venice in multiple data centers and checks that the active-active implementation is actually correct. And we found a ton of bugs thanks to that and fixed them, including some very gnarly like race conditions and super weird stuff. And I think there we have an interesting algorithm where we managed to make this verification very scalable because there's a high volume of data coming in. So we started off with a kind of naive implementation that we could run on just a small sample of the data because it was just too expensive to verify everything. And then we kept optimizing it. And now I think we have a pretty interesting algorithm that I hope we can publish some info about at some point. Actually, I have a colleague of mine at the conference named Zach, who knows a lot more than I do about this. So if you want to chat with him, you can find him.
Yeah, thanks. That sounds great. I mean, it's wonderful to have a whole new piece of open source software for everyone to play with. And I think you hinted at there maybe even some more experimental things to come. The roadmap's like long and got things you want to make more rock solid. I think you used the expression. Was there anything else you wanted to share about Venice or Vinci we haven't covered?
Well, what I'm most excited about is seeing in which ways the community tries to extend the system. So I think we have a few different interfaces that are prime candidates for getting alternative implementations of them contributed. Our storage engine, for example, leverages JUXT CV, but it is actually pluggable. So it could be interesting to see, are there use cases for different data structures to be plugged in? Like whether it's you could embed a SQLite in there, you could embed a Lucene index or whatever, and then so forth, other types of access patterns. And there are a few different areas like this in the system that I think would be exciting to see what people want to plug in. So we'll see. We'll see.
Yeah, we'll build it and they will come. Well, thank you once again for joining us today. It's been a real pleasure to speak with you. What's the easiest way that people can get in touch with you should they have some questions?
So they should go to the GitHub page, github.com/LinkedIn/Venice. And in there, we've got a few community resources. We've got a Slack workspace. We've got a LinkedIn group, a Twitter handle, so they can interact with us with any of these channels.
Awesome. All right. I hope you enjoy the rest of the conference. Thank you very much.
Thank you. Thanks, Jeremy.